Hello, fellow mathematicians. In this video, I would like to prove the law of sines. So this is a pretty cool trick that you can use, because usually when you're solving triangles, sine lengths, or angles, or whatever, you can only really work with right triangles, right? Because you need a right triangle in order to do sine, cosine, tangent. But what if I told you that there is a way to skip this entire thing if you have a certain amount of information? So, the law of sines is essentially saying that if I have an angle pair, so for example, let me say this is A, this is B, this is going to be like this. Okay. So the sine of the angle, like the ratio that it makes between both of these over the opposing side length is going to be equal to the ratio of another one of these guys. Oh, that is a weird B. So this is essentially the law of sines. Now, whenever I'm given this just a random equation, I think, okay, so you say this is true. Well, prove it, because that's how I like to learn. So I'm going to prove why this actually works, and I'm going to use this triangle to do it, because in case you haven't noticed, this is not a right triangle. Okay, so let's get started. So first things first, I'm going to start labeling things. So I'm just going to say that this is angle A, and this is going to be angle B. Then I'm going to say this side length is uppercase A, this one's going to be uppercase B. And now, what I'm going to do is I am going to draw a line here, and I'm going to create two right triangles. That's pretty cool. So now we can actually use SOHCAHTOA to help us out here. So I'm going to call the length of this side length right here, this side length, I'm going to say that this is x. It's going to end up being kind of a filler. So we want this to be in terms of these four variables. So let's see what we can do. So this is the law of sines. Let's see if we can use sines at all here. So I'm going to see what sine of A ends up being. So remember, SOHCAHTOA. So the sine of A, the angle A, is going to be opposite. So x is opposite in this case. Going to be opposite over hypotenuse, which is going to be B. All right, look at that. So we're already kind of looking weird. We don't really want A and B in the same equation here, though. So let's just continue on. Now let's look at the sine of B and see what we get from that. So the sine of B is going to equal to opposite. So this length, well, hey, this is the same length. We have another x here. That's kind of a little bit of a hint as to what comes next. Oh, and then over hypotenuse, which is A. Okay, so we have two of the same variables here. Whenever you have two equations and you figure out that there's two variables like this, that's kind of a clear thing that we want to use substitution. So what I'm going to do is I'm going to get these both these x's by itself. So for this equation, what I'm going to do is I'm going to multiply both sides by b. So if I multiply this side by b, that's going to cancel out that b. But then I'll multiply the other side so it's still the same. So b times the sine of angle A is going to be equal to x. Okay, now I'm going to do the same thing here, except for I'm going to multiply both sides by A, just like that. Okay, that's going to end up like this. Sine of B is equal to x. Okay, so now both these things are equal to x. So since they're both equal to x, I can essentially set them equal to each other. So we know B times the sine of A is going to be equal to A times the sine of B. And then, really, you kind of do, this is kind of an equation that you could use without having to look at whatever x is here. You could just look, okay, B, A, angle B, angle A. But sometimes, usually we like to keep them as pairs. We kind of want angle A and then side length A to be on the same side of the equation. Okay, so what I'm going to do is I kind of want to get B over on this side. So what I'm going to, so it's still not the best because I kind of have to divide, but it'll be worth it. So I'm going to divide both sides of this equation by B. So these cancel out. So now I end up with the sine of A is equal to A times the sine of B divided by B. So now I'm going to divide all of this by A. Okay, these A's are going to cancel out, and then I'm going to divide that side by A. So this looks kind of messy, but I end up with the sine of A divided by A is equal to the sine of B over sine length B. And here we go. This is the law of sines. So hopefully now you have an idea of where this seemingly random equation comes from. And it's pretty easy to solve. All you have to do, if you ever end up on a test or something, or a random guy walks up to you on a street, like Sal always says, you can think about it this way. Okay, I have two angles here, two side lengths here, and then I have this kind of middle ground person. So then you're going to take sine of this guy, and then you're going to end up with x's on both sides, and then you essentially solve it from there. So anyway, I hope that made sense. If not, there are other amazing resources out there like Sal and Khan Academy. But anyways, I wish you luck on your future math endeavors, and thanks for watching.